Hello, welcome to Einstein's Mechanics. Today we have a problem to solve, and it is going to base on resolution of forces. That is 2D resolution of forces. It's quite simple, and we are going to go through together. I hope you like the video. Subscribe and share your video with other friends. This is the problem. Determine the x and y components of each of the forces shown and find their resultant. You are to determine the x and the y components of each of the forces shown and find their resultant. So, this is a system being acted upon by some forces. We have 80 Newton force, 120 Newton force, and a 150 Newton force with the respective angles given. And we are to resolve these forces into their x and y components. I hope this is quite easy and an interesting question. So let's go through together. We have our solution. Please pay attention here. So let's write down the parameters. We have our F1. So let's F1, which is the first force, be the 80 Newton force. So 80 Newton force. And it makes an angle, which is our theta 1, with the x-axis as 40 degrees. Are we okay? Let's consider our F2, which is the second force. F2 is 120 Newton force, and it makes an angle theta 2 with the x-axis. This will be the 30 plus 40 angle, and that is going to give us an angle of 70 degree. Our F3, the third force, is 150. So we have 150 newtons, and theta 3 is going to be, what angle does it make with the x-axis? That's 35. So we have 35 degrees. So with this, we have all the parameters listed. Let's try to resolve them into x and y components. So first, let's consider from the 80 Newton force, from the first force. How do we resolve this into its components? Remember, if we are to resolve this into its components, we are going to have this 80 Newton force written in this form. So this is the force at the y and the force at the x. And this is the 80 Newton force. Are we okay? And it makes an angle theta 1. So let's call this force on the x1 because we are going to do for 3 forces. Let's call this y1. Are we okay? So this single force 80 can be resolved on the x and can be resolved on the y. And we know that if we are going to resolve this onto the x, that will be the force, which is 80 cos theta 1. And on the vertical, that will be 80 sine theta 1. So let's try to, our fx1, force resolved on the x, that is going to be our 80 cos theta 1, which is theta 1, 40. And when you punch this, you are going to get, this is a 40 degree. This is going to give us 61.28 Newton. When we resolve F on the Y, it is going to be 80 sine 40 degrees, and this is going to give us 51.42 newtons. Are we okay? So this is for the 80 Newton force resolved on the X and the Y. Now, from the 120 Newton force. We can also do the same thing. If you are going to draw it, it is going to be in this form, such as this. This is the 120 Newton force. It makes an angle of 70 with the x. So this is force resolved on y, force resolved on x. Let's call this x2, y2. Are we okay? So the same principle, F resolved on the x2 is going to be the force 120 cos the angle it makes with the x, which is 70. Remember, they are all in the positive direction of the x, so everything is positive. Here, the A, which is the 80 Newton, is in the positive direction of the x. The 120 is in the positive direction of the x as well. Looking at the y version, it is also in the positive direction of the y, so it is positive here. And this 120 cos 70 is going to give us 41 newtons. The force resolved on the y2, that is going to be 120 sine 70. And with this, it is going to give us 112.76 Newton. This is for the 120 Newton force. And the last one, from the 150 Newton force, we can also resolve it x and y. And when we draw, it is going to be represented in this form. So this is force resolved on the y3. Let's call this force resolved on the x3. And this is the 150 Newton force. It makes an angle of 35 with the x. Remember, now this 150, it is in the negative direction of the x, but in the positive direction of the y. So we are going to take into account the negative and the positive. So F on the x3 is going to be, because it is on the negative side of the x, negative 150 cos the angle 35. And this is supposed to give us negative 122.8 Newton. The force on the y3 is also positive direction for the y, and that is going to be positive 150 sine 35, and this is giving us 86 Newton. So with the first part, determine x and y component of each of the forces. We are done with that. And find their resultant. We are to find the resultant for the three forces. It is quite simple. So now the resultant can be resultant of the force. Let's call it R. Our R is going to be equal to find the resultant for series of forces acting this way. It is summation of the forces on the x square plus summation of forces on the y square. Are we okay? So let's try to sum the forces on the x for each of the forces. So summation of forces on the x, that is going to be for fx1, fx2, fx1 plus fx2 plus fx3, and the summation is going to give us a simple answer of negative 20.52 newtons. You sum 61 plus 41 and plus negative that. The same thing for summation of force on the y, which is going to be fy1 plus fy2 plus fy3, and this summation is going to give us an answer of 250.18 Newton. You also sum 51.42112 and the 86 to give us 250.18. Are we okay? Now this is the formula for the resultant. Root of the summation of x square and that of the y square. So let's try to get this part erased and finish whatever we are trying to do for the resultant. So let's put the values in, which is our r is going to be the square root of summation of the x, which is negative 20.52 square plus 250.18 square. Square root covers everything. When you punch this, our resultant force R is going to be 251 newtons for that. Very simple. So for the series of these forces, their resultant is 251 Newton. It's quite simple. Thank you for watching this episode. Watch out for the next episode.